All right, here we go. Last part of our video. Okay, anytime you see a capital D, that means dilation. Okay, and we're dilating by a scale factor. Anytime your scale factor is greater than 1, we are going to have an enlargement. So our picture should be getting bigger in this particular picture. All right, so what I'm going to do is take a moment and I'm going to write down the original X and Y for G, H, E, and F. All right, and then to get the new picture, I'm going to multiply each X and each Y by 2. So I'm just going to do times 2 for each X and each Y to get G, H, E, and F prime. So for G prime, I'm going to get 2, 4. So I'm going to go over to 2 on the x-axis and then up to 4 and plot my point. For H prime, I'm going to get 4, 0. So I'm going to go over to 4 on the x-axis, plot my point. For E, I'm going to get 0, -4. So I'm going to stay at 0 on the x-axis and go down to -4. And then for F prime, I'm going to get -4, 0. And then I'm going to connect all my dots. And sure enough, my picture does enlarge. All right, and then in number 14, instead of us giving us a graph, they just gave us coordinate points. Okay, again, like I said, anytime if we're having a dilation that's greater than 1, that means we are enlarging. This time it's less than 1, half is less than 1, so that means we're having a reduction. The picture will be getting smaller. So for our new coordinate points for D, U, K, and E prime, I'm going to multiply each one of them by a half. So D prime, half of 4 is 2, so that's 2, 2. For U prime, half of 2 is 1, so that's 1, -1. For K, half of 0, or 0 times 1/2 is just 0. And then half of 1 is 1/2, or 0.5. It really doesn't matter what you pick. For the 9-week test, you'll either have as written as a fraction or as a decimal, so it really doesn't matter. And then for E prime, okay, you might want to get your calculator out for this one. Okay, I'm going to do -5 times 1/2, or just -5 divided by 2, and that gives me -2.5. And then half of 7, divide 7 by 2, or multiply by 1/2, and that gives us 3.5. So if you want to write that as a decimal or as a fraction, it does not matter. Your answer choice on your 9-week test is multiple choice, so it will only have one of those answers with decimals or fractions. All right, and then the next 3 problems, we're going to be writing the rule of the transformation. So remember, we go from the original figure. So in this particular figure, we're going from the black figure to the red figure. So we're asking ourselves, how do we go from J to J prime? What happened? Okay, our shape stayed the same way. So it looks like we translated. So let's see, did we translate over to the left 1, 2, 3, and then down 1? That definitely looks like it. So we translated, so I'm going to do capital T. If we go to the left, that means that we are subtracting from our x value, so that means it's negative. And then we shifted down 1 on the y, so that's -1. Let's double check and make sure that that happened for I. We shifted over 1, 2, 3, down 1. Yep, that's how we got to I prime. 1, 2, 3, down 1. Perfect. 1, 2, 3, down 1. Awesome. Okay. In number 16, okay, we're going from the original to the new, okay, and we're trying to figure out what is happening. So we went from the black to the red, so we definitely had an enlargement. So that means that we dilated. Okay, let's see how we dilated. How do we go from G to G prime? So let's see here. I'm going to write this out to the side. G's original coordinate point was at 1, 2. And G prime is at 2, 3, 4. 2, 4. How do we go from G to G prime? So that means, remember, we are multiplying. We're either multiplying by a whole number or we're multiplying by a fraction. So to go from 1 times what gives me 2? So that multiplied by 2. And then 2 times 2 is 4. So we enlarged by 4. So the dilation, no, excuse me, not by 4. We enlarged by 2. So our dilation is 2. And then for our next one, we're going from the black figure to the red figure. So from K, L, and M to K prime, L prime, and M prime. And this looks like a rotation. So let's see here. From L to L prime, looks like we rotated just 90 degrees. So let's see if our 90-degree rule is right. So if it's originally X comma Y, our new, we're going to switch them first. And then our new X becomes negative. So if L, the original L, was at 1, 4, then the new L, if I rotated it 90 degrees, we should flip them. 4 comes to the front, 1 goes to the back, and then we change the sign of the new X. So that's negative 4, 1. So let's check it out. 1, 2, 3, 4, up 1. Perfect. So we did rotate 90 degrees. So R, little r, and that's 90 degrees about the origin. Okay, and number 18 is asking what type of symmetry it has. Okay, we know that this star does have vertical symmetry. We can cut it straightly in half, fold it like a hot dog style, and it's going to map on top of itself. If we fold it like a hamburger, horizontally, that doesn't even look horizontal. That's not going to lie on top of itself at all. Okay, but we know it has more than just one line of symmetry. Okay, I know that from this little point directly straight across, I can fold it along that line and the star match on top of itself. I can go to the next point, draw a straight line through, and it map back on top of itself. I can go to the next point, draw a line straight through, and it map on top of itself. The next point, and so on and so forth. So technically, this particular star has 5 lines of symmetry, okay? One particularly being vertical, okay? And it has rotational. Remember, when we rotate, we're asking ourselves, how many times can we rotate the figure and it map back on top of itself? And remember, we rotate counterclockwise. So if I take this original point up here at the top, how many degrees can I rotate it and it map back on top of itself? There are 5 points to this star. So I'm going to take 360 degrees and divide it by 5. 360 degrees divided by 5. And my rotational symmetry is going to be 72 degrees. About the origin, 0, 0. So 5 lines of symmetry. One of those 5 is vertical. Okay, and then we have rotational symmetry, which is 72 degrees. All right, and then 19, A and B, it says in number 19, A, it says write a translation rule if J is negative 2, 4, and J prime is 5, comma 2. So how did we move on the x-axis? We went from negative 2 all the way to positive 5. So how did we move from one x to the next x? Okay, if you're not sure, you can use a number line. If you want to write it as an equation, you can write it as an equation. X plus negative 2 equals 5, and you can figure it out from there. We added 7 on the x. So if you need to count, negative 1, 0, 1, 2, 3, 4, 5. That is 7 units. We moved on the x-axis to get from negative 2 to 5. And then for our y's, how do we move on the y? How do we go from 4 on the y-axis to 2? We subtracted, and we went down 2. So that is our translation rule. Okay. And then letter B, it says write the rotation rule if E, the original E, is negative 2, 4, and E prime is 2, negative 4. So our rotation. Okay, notice that X and Y stay in the same spot. So the only rule where X and Y stay in the same spot is going to be 180. And then remember the additional part to 180's rule is they change signs. So the opposite of a negative 2 is positive 2. Opposite of positive 4 is negative 4. So yes, we definitely rotated 90 degrees about the origin. And those are our 2 answers. And that is it for your Chapter 4 review. If you have questions, make sure you come and see us during advisory if you have any extra questions. I hope you have a great day, and go Rebels.